Assalamualaikum warahmatullahi wabarakatuh. My name is Afif Najib bin Hagzul. So my nomenclature is CE200-106. So this is my presentation for group project in this assignment for wireless and mobile communication. So the title this project is the cellular network in Parit Raja Johor, Malaysia. So for introduction, this research project aims to provide a comprehensive understanding of a base station in cellular network, which serve as the cornerstone of the communication in today's digitally connected world. And the project focus on the assessing signal strength and quality at various base station in a specific area using performance metrics such as RSSI, RSRP, and RSRQ. For the third point, it also synchronized the handoff process for the preserving unit interrupted service and inspect the design of the base station. And then furthermore, the project investigates the correlation between signal strength and propagation for loss factor and the distance between mobile phones and the base station. And lastly, the goal is to analyze the base station characteristic and signal coverage truly the deriving valuable insight into the performance and coverage of the wireless network in the selected area.
So moving on to the next part, which is methodology. This is the project was conducted in Parit Raja Johor, and 3 mobile base station was selected at 3 different locations. So the first location, which is Kampung Parit Bengkok, Jalan Parit Karjo, and lastly the Kampung Teriman. So the site location is important factor in studying the handoff process mobile phone between two towers from point A to point B within a telecommunication network. So this is the base station 1, 2, and 3, and measure location to measure the power receiver from the mobile station and the distance between mobile base station and the measured location. So in this project, we are going to use SendMapper to measure the power received on the mobile application. So the SendMapper provides the power receiver and the GPS location, so we can get the precise location for our measured location.
Assalamualaikum, my name is Nimam Afif bin Ibrahim. The matrix number is E200021. Reason to taken the formula that we use. First formula is free space path loss, which is FSPL equal to 32.45 plus 20 log F plus 20 log E. The 32.45 is the constant unit. It derived from the speed of light and the conversion of between dB and natural unit. For the 20 log F frequency, this term revision for the frequency planar loss. And then for the 20 log E distance represent for the distance dependent loss. For the second formula, we will find the Okumura, which is L50 equal to FSPL plus AMU bracket frequency and distance minus GHD minus G area. For the FSPL is the free space path loss that we find for the first formula, and then the AMU is the median attenuation relative to free space, and then the GHDE is the base station antenna height, and the G area is the type the gain due the type of the environment. For the third formula is power received, which is PR in dBm equal to ERP plus GR minus L50. For the ERP is total power that radiated by the transmitter, and then we plus with the receive antenna again, and then we minus with the Okumura. For the analysis, data, and discussion, there are 3 base station areas that we contain the chosen location. Altogether, data will be used to determine the level of the power received and the potential contribution to propagation loss. We will use the 3 of the formula that I have mentioned earlier. Using the following approximation, plot points of AMU and the J area is used for a number of frequency Okumura model. By using the following approximation, the plot point of AMU and J area is used for a number of frequency in Okumura model. For our base station, the frequency is 2162, and the area of our location is suburban. Then the J area is 12, and then for the other base station, the frequency is 1870. Then the J area for the frequency is 11. It is 11.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azhar Haziq bin Jasmani. My matric number is CE200138. Today I will present to you about the manual calculation for this project. As you can see, for the checkpoint 1, for the base station 1, the longitude is 1.848265, and for the located for the mobile station is 1848342, and the distance from the base station and mobile station is 0.116 pm. Okay, for the formula, firstly, we find the FSPL and we get the 18.44. Next, we go to L15, that's Okumura, and we get the nilai value FSPL to the Okumura formula, and we get the 113.69. And lastly, we turn in the PR power receive dBm formula. That's 25. The formula for the we choose the tune the EIRP, and plus 5 minus 113.69, and we get the negative at 3.69. As you can see, at the cell mapper, we RSRP, we get the negative 91 dBm. Okay, for the checkpoint 2, base station 1, and go to base station 1 and mobile station to the distance is 0.522 km, and we get the power received is negative 69, negative 96.75, and for the RSRP we get same 96 dBm. Okay, for the second third checkpoint, you can see we get negative 102.75, and for the RSRP at the cell mapper we get the negative 98 dBm. That's checkpoint 4. We get the power received negative 107.97, and the RSRP at the cell mapper we get negative 124 dBm. Okay, as you can see, the different location, the dBm is increased. So the long from the base station, higher the dBm we get. Okay, for the base station 2, for checkpoint 1, as you can see, the hands off at the checkpoint 4 and checkpoint 1. Okay, for the checkpoint 1 for the base station 2, the distance for the mobile station and base station 2 is 3.89 km, and the power received is negative 116.94. At the cell mapper we get negative 114 dBm. Next is checkpoint 2. The power received is negative 113.967, and the RSRP at the cell mapper is negative 101 dBm. Okay, that's the distance for the mobile station and base station and the mobile station, 2.67 km. Okay, for the checkpoint 3 for the base station 3, as you can see, the distance is 0.01 km. The behind the mobile station behind the base station, and we get the negative 65.14 power received, and the RSRP is negative 75 dBm. And lastly, for the checkpoint 4, we get the PR negative 95.5 WAM, and the RSRP is negative 102 dBm. Okay, for the base station 3, for the checkpoint 1, the distance from the base station 3 and the mobile station is 3.67 km, and the power receive we get a negative 114.69. The RSRP at the sample we get the negative 113 dBm. Okay, for the checkpoint 2, you can see the hands off for the checkpoint 4 and the checkpoint 1, the station 1 and 2. Checkpoint 2, the distance for the mobile station and the base station is 2.89 km, and the power receive we get negative 112.61. The RSRP we get negative 114 dBm. Okay, for the checkpoint 3, the distance 1.06 km, and power receive we get negative 103.90. The RSRP is negative 110 dBm. Okay, for the last checkpoint for the base station 3, the distance 0.04 meter, and the power receive we get negative 75.44, and the RSRP at the cell mapper we get negative 84 dBm. As you can see, the simple conclusion, yeah, for the simple conclusion, when we close at the base station, the RSRP or dBm will be increased.
Okay, Assalamualaikum and very good evening. My name is Muhammad Nabil Farhan. I'm from Group 4. Today I will present you in this slide the parameter of each base station with their checkpoint. Each base station has a 4 checkpoint. For example, the base station 1 has 4 checkpoint, base station 2 has 4 checkpoint, and base station 3 has a 4 checkpoint. Each checkpoint has a different distance. So the checkpoint 1, the distance from checkpoint 1 to base station 1 is 0.116 km, and checkpoint 2 is 0.522 km, and checkpoint 3 is 1.042 km, and checkpoint 4 is 1.9 km. So after we get for the checkpoint 1, the free space path loss is 80.44, and we G area we use a 12, and we get the Okumura is 113.9.69, and after we calculate all, we get the power received. For the we calculate, we get a negative 83.69, and compared to the power received in cell mapper we use, we get a negative 91. In the checkpoint 2, the free space path loss we get 93.50, and the Okumura we get 126.75, and we get the after we calculate all the power received PR we calculate, we get a negative 96.75. Compared to the power received in cell mapper, we get a 96. Before that, I forgot to tell you the EIRP we set for the base station 1 is 25, and for the base station 2 is 22, and for the base station 3 is 24. We tune for the base station 1 is 25, base station 2 is 22, and base station 3 is 24. Continue that the checkpoint 3, we get the free FSPL, we get the 99.50, and we get the Okumura is 132.75, and we get the power receive after we calculate all, we get a negative 102.75 compared to the power received in cell mapper is negative 98. And for the last checkpoint in base station 1, we get the FSPL, we get 104.72, and we get the Okumura L50, we get a 137.97, and we get after we calculate all, we get the power received, we get negative 107.97 compared to the power received in cell mapper is negative 124. Continue to base station 2, the distance from checkpoint 1 to base station 2 is 3.89 km, and from the checkpoint 2 is 2.67 km, and from the checkpoint 3 we get the 0.01 km, and last checkpoint 0.33 km. And the AIRP we tune for the base station 2 is 22, and the FSPL for checkpoint 1 we get 109.69, and the Okumura we get 143.94, and the power receive we calculate we get negative 116.94 compared to the power receive in cell mapper is negative 114. For the checkpoint 2, the FSPL we get 106.42, and the Okumura we get 140.67, and the power receive we calculate we get 113.67 compared to the power receive in cell mapper, which is negative 101. For the checkpoint 3, we get FSPL 57.89, and the Okumura we get 92.14, and the power receive we calculate we get negative 65.14 compared to the power receive in cell mapper negative 75. For the last checkpoint for base station 2, the FSPL we get 88.26, and the Okumura we get 122.51, and the power receive we calculate we get a negative 95.51 compared to the power receive we get from cell mapper, which is negative 102. So continue to the base station 3. The base station 3 has 4 checkpoint. For example, one checkpoint first, the distance first checkpoint to the base station 3 is 3.67 km, and from the checkpoint 2 to the base station 3 is 2.89 km, and from the checkpoint 3 to the base station 3 is 1.06, and from the checkpoint 4 to the base station 3 is 0.04 km. In the first checkpoint, we get the FSPL is 110.44, and we get the Okumura, we get 143.69. To get the power receive PR, we tune the EIRP for the base station 3 is 24, and we get the power receive for calculation power receive we get negative 114.69. So compared to the power receive in cell mapper is negative 113. For the checkpoint 2, we get the FSPL is 108.37, and we get the Okumura we get 141.61, and we get the power receive we calculate we get negative 112.61 compared to the power receive in cell mapper, which is negative 114. Compared to the for the checkpoint 3, the FSPL we get 99.65, and we get the Okumura for the checkpoint 3 is 132.90, and we get the power receive we calculate 103.90 compared to the power receive in cell mapper, which is negative 110. For the last checkpoint for base station 3, we get the FSPL 71.19, and the Okumura we get 104.44, and the power receive we get the negative 75.44 compared to the power receive in cell mapper we get, which is negative 84. So after that, we build a graph power receive in 3 base station. As you can see in the figure, we see the BS1C is stand for the base station 1 calculation, and BS1M is for the base station 1 measure, while BS2C stand for base station 2 calculation, and BS2M is stand for base station 2 measure. The BS3C stand for base station 3 calculate, and for the BS3M stand for the base station 3 measure. So in this graph has a 6 line, each representing a different combination of base station and a channel. The line show that the power decrease distance as the distance increase, but at the different rates depending on the base station channel. The graph can help us understand coverage and quality of wireless communication in different areas.
For conclusion in this project, the research project conducted in the Parit Raja Johor focused on the understanding base station in telecommunication network. 3 base stations we analyzed using the cell mapper application, and the result validate the reliability of the base station design and the effectiveness of Okumura model. The project helped the student understand the cellular system, the handoff process, and how to analyze the network performance using propagation models. The project's finding can be used for future research in telecommunication, highlighting the importance of handoff learning.
And then the question one asks what the type of delegation environment is chosen, and we choose the Parit Kajo as our site location. It is located in a low area in Batu Pahat with a environment dominated by the fruit farming. That's all from me. Thank you.
Okay, for the question, how do you measure the distance between BS and MS? Okay, as you can see, we are using the calculator.net to calculate the distance from base station and mobile station. As you can see, for the example, we using the checkpoint 3, base station 2 to the mobile station at different 0.01 km. And for the calculation, manual calculation to get the distance, we get the 0.0017 the result for the value for the distance mobile station checkpoint 3 to the base station 2. Okay, that's all from me. Thank you.
So we continue for Q&A session. So I'll choose the question 3. What is the estimate cell radius of the chosen site? So the answer, the radius of a site cell in a cellular network is usually determined by the maximum distance at which a mobile device can still maintain a good quality connection to the base station. This can also to be linked to submission handoff. Also known as handoff is the process of mobile device switching from one base station to another base station while a call is in progress. This usually happen when the device move out of the coverage of one base station and into coverage area of another. So for example, as you can see on this table, the mobile device from base station 1 with distance 1.9 kilometer, then the power receive 107.97, which move to base station 2 with a distance 0.034, then the receive power 75.77. So this is indicates a handover process occurred when the mobile device change and or move to another base station. So same this with situation where the process the off and off also happen. So to estimate the cell radius is to determine the threshold for the minimum power level received. For example, if we consider 100 dBm as a threshold, then the for base station 1, the radius of the cell is about 1.042 kilometer. Because this is a maximum distance where the receive power exceeds 100 dBm. So that's all from me for this question. Thank you.
So the estimate gain receiver of the mobile station. The gain of the receiver of a mobile station in Malaysia is typically set to the 5 dB to ensure the sufficient signal to noise ratio (SNR) for effective communication. This value is significant as it may require for a 10 MHz bandwidth signal at antenna port of the mobile device received.